welcome out to EXL, and I can't see it on 325, how to design your Lync 2013 deployment to be well actually, that's not what we want, disaster proof, right? So we're going to talk about high availability and disaster recovery in Lync 2013, the changes that have been made, and we'll show you some demos of that functionality, assuming that our demo environment works well, to show you what that experience will be like from an administrative perspective. So in this session, what we're going to talk about is the changes we've been making in Lync over the past few years. You saw us in Lync 2010 do a large job of consolidating server roles and try to consolidate administration among the different platforms and functionality we had. And we started down the automatic availability path for voice. So if you have two Lync 2010 pools, you can have voice failover. And so users who are enabled for enterprise voice will have that voice functionality in case of a primary pool outage. The feedback we got from customers, though, is that Lync is primarily deployed for instant messaging and often for conferencing. Voice is a subset, typically, of the user workload. It's a rapidly growing subset, but the core functionality was kind of left out, right, from an automatic failover perspective in 2010. And so we heard that feedback loud and clear, and we wanted to make sure that the failover experience from that instant messaging and conferencing aspect can be as robust as what we see on the voice workload. And as we point out in the bottom right-hand corner there, as much as possible given the time constraints. So essentially, we ship our software every couple of years. Typically, it's 2 to 3 year ship cycles. With Lync, you've seen about an 18-month ship cycle just due to the rapid change and rapid pace of change in the UC environment. And so every 18 months, right, we have to make a decision, and we ship the software based on where that availability and functionality is at that time point. But core points was really to try to drive out or remove the single points of failure whenever we could. So in terms of SQL, we added this concept or support for SQL mirroring. We'll discuss some of the SQL concepts around that. We also tried to remove a lot of the Lync dependencies on that backend SQL server itself, and that will have some direct applicability as we look at some of the pool failover capabilities. We also used to have a mode in Lync 2010 called Metropolitan Site Resilience. That allowed us to extend a pool across more than one location, and so therefore, if that location failed, the pool would survive. We'll explain why we don't think that's a poor, or why we thought that was a poor choice, and remove that option in Lync 2013. So high level, right? We'll take a look at kind of the history of changes over time. In OCS 2007, R2, and in Lync 2010. For a server failure or a front-end server inside of a pool, we use a combination of a hardware load balancer and DNS load balancing. Clients or Lync clients and Lync Phone Edition devices can use DNS load balancing. They have the logic built in to query the servers in the pool and automatically determine the appropriate front-end server that they should work with. If that turns out to be unavailable, they know how to fall back automatically to additional servers. We require the hardware load balancing aspect for web services. We have some portions of the client, such as querying the address book, for example, right, or other aspects that will query a web service, and other clients and types of functionality that require HTTP requires a hardware load balancer, as we don't have that concept of DNS load balancing for HTTP-style traffic. At the back end, traditionally, we've done database exports and database backups and provided some clustering for availability in the previous versions. With Lync 2013, we moved to the concept of SQL mirroring or synchronous SQL mirroring to ensure that we have more than one copy of that data. Therefore, a SQL server or a data storage outage on that backend server will ensure that the other node can resume, have a full copy of the data, right, and therefore readily service that Lync pool and provide some capabilities. If we add the concept of a witness to that environment, we can have automatic failover on that back-end scenario, and that ensures that we don't even need any administrator intervention in the case of one of those back-end node failures. For the pool concept, as we noted, we started down this path with Lync 2010. We gave you the option for pool failover for voice on the concept of a stretched pool in case you needed to have a site-resilient topology. However, we've modified this approach, right, in Lync 2013 to improve upon this concept of pool failover and remove any concept that links infrastructure such as a pool between sites. So we want this concept of complete separation of services so that a total or a catastrophic pool failure or site failure at one location we're able to rapidly resume or recover, either automatically for some functionality such as voice and or administratively for other functionality such as your instant messaging and or conferencing in these types of scenarios. So we're going to spend quite a bit of time talking about these pool failover changes as we walk through the session this afternoon. And finally, the concept of site failure. That's directly applicable in the Lync 2013 to pool failure because we recommend that the pool stay constrained to a site. When we have a site failure, that pool would fail over to its associated backup pool, and the clients associated would re-register and regain their services on the other side. So the way we broke out this session is to kind of walk through the HA and site resilience options. For high availability, we've got a couple of choices. There's the front-end aspect, which we'll talk about first, and then that back-end or SQL aspect, which we'll talk about second. From the front-end perspective, it's very straightforward, right? We kind of refer to that as autopilot, or the autopilot reference. So you shouldn't have to do anything as an administrator. The front-end failover experience is designed to be fully automatic. There is no administrator or administrative action required when we have that outage at the front-end server layer. So if we look at a typical Enterprise Edition pool, we have that back-end SQL server, could be an individual node or could be a SQL mirror. And in the case of an outage of any one of those front-end servers in the pool, the client will detect that the server is down, client will automatically go and re-register to a different server in that pool via an algorithm on the client. So all clients will get a list of all the front-end servers in the pool, randomize that list unique per client, and then attempt that connection sequence in order. So they are aware of the other servers that are available and will automatically start that connection process. No data loss in this scenario, right? The data is being replicated between those front-end servers. The transient data and the persistent data is being queued up for storage back on that SQL backend. So I mentioned this concept of data replication between the front-end servers themselves. For that replication, it turns out that Windows Server has a data replication model that's available for us to leverage that's known as the Windows Fabric. And so with Windows Fabric, we can write data to this concept, and this will then be replicated amongst the front-end servers in the pool for us, and therefore have that data when a user fails over to one of the other nodes in that environment. In Lync 2013, the way that we accomplish this is by this concept of user groups. So we have this concept of user groups. Each user group consists of 3 nodes inside of that pool. Those would be 3 different nodes, right, per user group. And there's a primary, a secondary, and a tertiary node associated with that user group. The user will always try to log on to the primary inside of their user group. If it's not available, they'll log into the secondary, where a copy of that user's data is stored. And if that secondary is not available, they'll log into a tertiary, right, et cetera, to support this concept of automatic failover. This ensures, because we've replicated the data in advance, that we have fast failover times. The user just re-registers to an additional server in that user group in the pool. And we can dynamically scale and load balance the connections among all the servers in the pool without having to worry about balancing numbers of users per server or associating somehow users per individual servers in the pools. If we look a little deeper inside of this, I talked about the 2 types of data, right? There's both persistent data and transient data. So persistent data would be things that we want to back up or ensure that are stored on that SQL database so that in the case of a total front-end loss, right, we have that data set available. That's going to be things such as the person's contact list, their call forwarding settings, right? Any conferences that they schedule, for example. These are important settings, and so therefore we want them to be persistent across any of those front-end servers or data loss itself. We do have that information on the front ends, and we rely on this concept of chunking or submitting that data back to the SQL backend. So it's queued up on the front end and then written sort of at leisure, at convenience. What this queuing does is enable us to offload some of the requirements around SQL from a performance perspective. So with previous versions of Lync and OCSR2, SQL was a significant bottleneck as we had a lot of business logic and a real-time reliance on that data in SQL itself. Now that we're caching the data on the front ends and then lazy writes back to SQL, if SQL gets a little bit busy, for example, right, or if SQL is temporarily unavailable, we're not going to see that dramatic reduction in service from an end user perspective. We also have the concept of transient user data. Transient user data would be things like my present status changes during the day, right? So if I hop on the call or if I join a meeting and my present state changes from available to busy or away, that's not that important. We'll replicate that between the, we'll keep that on the front end that's there, but when a user re-registers to a different front end server, we don't have to have that information replicated because it's data that is dynamic and would occur during the registration process itself. So no requirement to replicate that. That reduces the load or the burden significantly from that concept of performance and scalability at the front ends themselves. From a conference perspective, we also make sure to replicate some information about those conferences. As we call out, right, the active conference roster and the specific MCUs that are in use during that conference. So if I have a conference with web sharing and audio, for example, the web conferencing MCU that's identified in the pool and the audio conferencing MCU that's running in the pool would be annotated or stored in that transient user session. That, of course, will be recreated, right, as a user calls, as we have a failover registration, or a failover on the front-end server, as those are still going to be running, and we can recreate them if the server that they were running on is the one that actually failed. We do have these shared blobs, right? That's essentially there for rehydrating data at the client. So when it signs back in, I'm able to pull down my buddy list, my call forwarding settings, right? These are things that we don't want to be lost in the case of a front-end server outage or a loss of functionality there. When we introduced the concept of the Windows fabric, we also introduced the concept of quorums. And so if you spent time with either SQL clustering or Exchange database availability groups, for example, over the past several years, you'll notice a reliance on this concept of quorum around availability. And with quorum, what essentially we're saying is that we want to know when we cannot talk to the other servers if that's a network condition or if it's the fact that other servers are actually down, right? So is it me being isolated or is there a loss of functionality in the environment? And we use the concept of quorum to have a vote. And so with quorum, as long as we have a majority of those nodes alive after whatever outage occurs, and those nodes can communicate with each other, they can declare quorum and they can enable functionality. What we're trying to avoid is the concept of split brain, where we have an outage at the network level, for example, and 3 nodes think that are okay on one switch, and the other 3 nodes are okay on the other switch, and they both try to service the same user population at the same time, right? Now we have some conflicts and some problems. And so by defining this quorum model, we ensure that we never have parallel operations without communications between those nodes. The nodes always have to be in communication, and we have to have a majority of those nodes in communication in order to declare a quorum. So with that, if we look at a pool of 3 servers, for example, or 3 or 4 servers, we need at least 2 nodes to be active in that in order to declare quorum. On the table here, it's a little bit confusing because we're showing both even and odd numbers. In this case, if we have an even number of nodes in the pool, we use the SQL backend to be the arbitrator or the tiebreaker. So we always have an odd number for declaring quorum. So if we have 4 nodes in the pool, we add the 5th as SQL. Now we need 3 out of the 5 to be in communication in order for us to declare quorum and continue servicing clients. If we have an odd number of front-end servers in the pool, so if we have 5 or 7 front-end servers in the pool, for example, right, then we would need a quorum of 4, or 4 of those nodes in direct communication in order to maintain the quorum and continue servicing or providing that functionality. If you'd like to see, right, or determine where those quorum nodes are and whether or not SQL is being used, you can go to the program data Windows Fabric settings.xml file, and in here you can see the section name under votes, and you'll see the servers that are identified as part of the pool. If we have an even number, as shown in the 2 server and the 4 server pool, you'll see that the SQL server is added to make that an odd number of votes, or an odd number of members, because once we have an odd number of members, it's easy for us to define a majority for that pool setting. This is automatic. There's no requirement as you add or remove servers in the environment to add the SQL or to modify the SQL instance for that scenario. We'll take care of that for you from the Lync perspective. If you attended the session this morning, we talked about the recommendation around a 2-server pool versus a 3-server pool. Though it's possible to deploy a 2-server pool in a Lync environment, the Microsoft recommendation is that the minimum number of front-end servers in a pool is 3. There's a couple of reasons for this. The first one is that the user group model, in terms of availability, has a primary, secondary, and a tertiary one. So 3 would give you the most availability of number of servers per user group and the functionality or breakout and priority along that. The second factor is that SQL, as we noted, is the third vote in that two front-end server environment. But in a SQL environment, if you have a SQL mirror established, only the primary node counts as that third vote. So if you had a failure on your primary SQL node and and a witness server, right, and it automatically failed over to the secondary, or administratively you failed over to the secondary, that primary is offline for maintenance or some other tasks. You have 2 front-end servers available. That means we have 2 out of the 3 requiring quorum. And so if you were to take one of those remaining 2 servers down for maintenance or patching, or it were to fail, the third one would go down as well because it's only 1 of 3 and we no longer have quorum. So from a quorum perspective, right, it's important to understand the complexities there when we're talking about number of servers in the environment to make sure that as we're going through operational tasks, we're able to maintain or ensure that we continue to have quorum. So as we call out, right, there's some guidance or some rules here when we start talking about this of how do we ensure that we maintain availability when we have a smaller number of servers in the pool. For example, right, we don't want to stop the Lync services on both servers in the pool at the same time. That's going to require a specific startup sequence for us to recover that process, as we call out in rule number 3. And also stopping the Lync services, right, is not going to affect the Windows Fabric ones that are actually using our quorum or our decision-making logic. Any questions on the front-end availability, front-end portions of the pool there? All right, let's talk a little bit more then about the back-end portion, or SQL, and some of the rationale that we use to change that. So our analogy here, right, is that when we talked about SQL clustering and SQL in the past year, we said the 80s are calling, right?
Why are the 80s calling?
Well, they want to know.
What do they want to know?
What happened to clustering, right? So we see clustering essentially like wheels. And if we think of clustering as wheels, then that would mean mirroring would have to be something else. And that would represent the future. So if we think about the future, we got hoverboards. So with SQL backend, the reason we went to the concept of mirroring, or we recommend the concept of mirroring, is that we have this concept of availability in the case of an outage. One of our most common support incidents is the concept of a storage system failure when that storage system was providing services for SQL or for Exchange and the applications that sit on top, right? So such as Lync or SharePoint. It's common. One of our most common scenarios, especially in the Exchange space over the past decade, was to see that concept of shared storage go down. All mailbox services are offline. In the OCS environment and the Lync environment, we see organizations deploy a SQL cluster, and that SQL cluster relies on shared storage again. When that shared storage goes down, the entire Lync or the entire OCS pool again has failed. And so we're trying to move away from this concept of that single point of failure. SQL mirroring provides us that option. With a SQL mirror, we have a primary node and we have a secondary or a subscriber node, and the data is replicated synchronously, ensuring that any data write to the first node, right, is written to the first node and the second node before it's acknowledged back to the host. This ensures that we have 2 independent nodes, each with a full copy of the data, and each able to service or reply to those front-end servers in the pool and provide functionality so that in the case of a catastrophic outage of either one of those SQL nodes, we automatically will retain functionality for that Lync pool, and that Lync pool will stay up and continue to service users. Mirroring requirements, we require that the nodes in the mirror have the same version of SQL, however, if you're using the witness, right, that could be a different version of SQL. It's easy, and potentially even SQL Express, we could use that on one of the other servers inside of the organization. It's relatively easy or straightforward to set up a SQL mirror. You can actually do this from the topology builder in Lync itself. You need 2 SQL instances. We recommend giving instances the same instance name. It just makes it easier from a configuration and administration perspective. You define the concept of a mirror, point at those 2 individual SQL nodes, and Lync will create the mirror and the functionality in SQL itself. Once the mirror is established, we're aware of both the primary and secondary, and if that primary is not available, we will redirect those front ends to talk to the secondary and use that as their storage area for that permanent data store that we talked about earlier. Failover impact. Our goals for SQL mirroring and failover for Lync was an RTO and an RPO of 5 minutes. As we call out also, it's a synchronous data replication process, so there is no data loss in that scenario. If we were acknowledging that the write was successful, that means that the write had completed on both nodes prior to coming back to the front-end servers itself. If in your SQL mirror you have a SQL witness, you have an automatic failover, no administrator intervention required. If you do not have a SQL witness and your primary node fails, you'll need to take administrator action to fail over to that secondary or your auxiliary SQL box inside of the mirror itself. During that failover process, if your SQL environment is unavailable, your Lync users are in what we call resilience mode. They will have some functionality, but not the same as if the full pool was available. And we'll show you in a couple of slides what that user experience is during that resilience mode or the resilience functionality. Obviously then, if both the principal and the secondary fail, same concept, right? You'll end up in resilience mode from a pool level. During the concept of establishing the SQL mirror and going through Topology Builder to configure this, you will need to create a mirroring file share. This is a temporary share that's used during the initial setup of the SQL mirror. We write some BAK files here as we're doing the initial configuration and setup inside of SQL. The primary server needs read-write access to the file share. The auxiliary server needs read-only access to that. It can go on any file server in the organization, any file share that you have. The two caveats that we say are don't use the Lync file share. That's for Lync conferences and meeting storage. This is just temporarily used for establishing or setting up the SQL mirror. And don't use DFS. DFS blocks the .bak extension by default, and so if you use DFS, you won't have and you point the mirror at that share, right? You're not going to see those BAK files. As we say, one-time share, we use it for creation of the mirror, and then it's no longer required. Mirroring also has a couple of TCP ports required for SQL. By default, those are 5022 and 7022. You can look those up in SQL Management Studio. We show the screenshots here, the process or the requirements around that. The next area that we cover is the concept of pool resilience, right? So sometimes pools fail, there's pool failures, but what we want to see is a pool failover, right? The healthy, clean pool and what happens when we have that pool failure in the environment. It's relatively straightforward. We have the concept of pools, and we're able to pair the pools in Lync 2013. A paired pool, essentially, they each back up each other, right? So we have a one-to-one relationship between these. Pool A has a backup as Pool B has a backup of Pool A. We declare this pairing relationship inside of Topology Builder in Lync 2013. Once we declare this paired pool relationship, we get some additional functionality, which we'll walk you through on the next couple slides. When we talk about a pool failover, one of the things we have to talk about as well is the concept of the central management store, or the CMS, and how that fails over. All Lync servers have a copy of the central management store, the CMS. There's one copy that's read-write, and all the rest are read-only. When you make a change in Topology Builder, that change is written to the read-write copy, and that is then automatically replicated to all other Lync servers in the organization. This ensures that Lync servers can survive in the case of a lack of access to the central management store, right? Each one has a local replicated copy. They will boot up and operate with the last known good config. While that read-write copy is offline, you won't be able to make changes. So therefore, we want to either seize that role, or if we're doing a planned failover event, right, move the CMS to the secondary location so that we can take the primary location offline. So if the CMS is in the primary, we'll move it with a manual set of commands, right? That way we ensure that post-failover, we still have the ability to modify or update the topology and have access to that read-write copy of the CMS. When going through to do this, it's quite straightforward, and it's actually probably easier to show than it is to go through and walk through the steps. So we'll turn it over to Ewan.
So you've got a couple of guys in conversation here, Greg and Aaron, just having a little chat. whilst Aaron's enjoying the conference, and Greg's back in the office. So what I've got here is a couple of users who are connected into a pool. And if I just show from the client perspective, control right click and go to configuration information, we can see that this user is connected into pool 1 for pretty much everything. And he's connected into FE1. In my environment, I've got FE1 and FE2 against best practice, but it's a lab environment. I've just got 2 servers in my pool, and the domain is un.mac because I'm massively self-obsessed, I guess. It seemed like a good domain name to use. So what I'm going to do is, from the administrator perspective, is look at some of the stuff that we can see that Andrew was talking about. So if I have a look at get CS user pool info for my user at un.mac, that's going to show me the primary pool FQDN for this user is pool1.un.mac, and the backup pool is pool2. If I was to look inside of Topology Builder, then Topology Builder would be able to download my existing topology. And in just a second, I didn't plan to do this. I'm just doing this on the fly. I'm literally making this part of the demo up as I go. So if I go into Topology Builder just to show you, I'll come back to that. That's taking too much time. So the user's connected into pool 1 right now, and we can also see the primary and the secondary and potentially tertiary machines that they connect into from the point of view of registering with the front-end service. So if I jump into my topology, we will see underneath Enterprise Edition pool, I have pool 1 with front-end server 1 and 2, and that has a SQL store of SQL 1, as we can see there. I've got it mirrored as well, SQL 1M, and we have an associated backup pool, if we go down to resilience, of pool2.un.mac. And we can see that that's the reciprocal relationship that was mentioned earlier on when we have a look at pool 2. And again, pool 2 is just a couple of servers, front-end 3 and front-end 4. Again, the resilience is going back to pool 1. So if I have a look at my CS pool backup relationship and have a look at the pool1.un.mac, that will show me that from PowerShell, or the link management shell, that my backup relationship with pool 1 is with pool 2, which means if this user decides to start a conference, we can start demoing some planned failover actions. So there we go. It's the only person on the call. I'll just start a whiteboard. And what we'll see is during some of the failovers, we get some different behaviors depending on what it is we're doing. Anytime now. It'll happen soon. There you go. It's always when you demo stuff goes slightly. All right, so just do a general scribble on the screen. That's about as artistic as I'm going to get for today. At this stage, what I'm going to do is assume that we've got some kind of potential problem or some kind of planned outage where we want to move the pool, the users pulled in pool 1 over to pool 2. And because pool 1 is running the CMS, I want to move that as well. So what I can do is get the CS management store replication status for my central management store. And that shows me, as you can see here, that we've got FE1 is the active master FQDN for the CMS. So I need to move that to the second pool. And to do that, it's a simple PowerShell commandlet, which is invoke management server failover. I have to specify my backup SQL Server FQDN, which is SQL2, and then my backup SQL instance name, which I've just simply called Lync. And we can force this if we want to. If we force it, that means ditch any deltas that potentially haven't replicated over. If we don't force it, then that means, do it gracefully. So I'll say $false for that. And what that's going to do is move the CMS over to SQL2 and pool2. And that will take a couple of minutes, which gives you some time to talk about the next few slides.
Excellent. All right. So while that's failing over, we'll talk a little bit more about this concept and the architecture behind paired pools. We talked about the concept of paired. That means each pool only has one backup, right? We can't have a tertiary or quaternary pool relationship in the organization. We'll have a pair. Each pool in that pair backs up the other pool. There's an automatic backup service. In Lync 2010, we did see some administrators manually script the instant messaging and the conferencing data that was in one of their pools, export that to a file, copy that over to the other pool location. If there's an outage, rehome the users, import that data, and provide a manual activation process. In Lync 2013, we've essentially automated that by putting in the backup service to automatically export that data, copy it to the other pool location, and have that ready for that in the case that that backup pool needs to resume service or activate service for the primary pool's users. The replicas all have a single master. In that case, it's the pool's blob store located in that SQL database. As we mentioned, there's both automatic failover. Automatic failover occurs for the voice workloads. During that one, we'll have users go into resilience mode, and they'll have voice functionality during that failover process. We also have the concept of administrator-activated failover. So to pull users out of resilience mode and permanently home them on that backup pool and restore essentially full functionality, you have to click a button or push the button to activate. So this ensures that in the short-term pool outage, right, users will rehome, they'll operate in resilience mode. If it's going to be a long-term outage, you push a button to activate them on that secondary pool, and they'll have all of their buddy lists, conference data, voice functionality, et cetera, available on that second pool. So let's take a look, right? We talk about this concept of resilience mode. What is that user experience for people when they have that primary pool outage and enter resilience mode as they start communicating with their backup pool? For users already logged in, they're signed in and connected, right? That at some point during that pool failover experience, you'll see the Lync client sign out and then automatically go back to sign in. Once you do the administrative functionality right, they will remain signed in, and they just go from resilience mode into normal operations. Their full contact list comes back, and they're able to resume any meetings that they had or any conferences that they had prior. If a new user signs in and the primary pool is unavailable, they'll sign in, they'll get the concept of resilience mode in the client, same result, right? They don't have to sign back out or sign back in once we activate or go to regular mode. For conferences that were organized by the affected user, those are going to be terminated. That's because the conferences that were initiated by a user that has to fail over, those conferences were being housed on their home pool. In a pool failover, that home pool is unavailable, so we don't have those MCUs available. However, the rejoin will appear, but while the user is in resilience mode, they can't rejoin those conferences. We have to rehome the user, right, with that activation process to say, yes, we want them now running off of pool 2. Once we hit that button, users will be able to rejoin their conferences and continue as they were prior. If the conference was being housed by or hosted by a user on pool 2, and pool 1 was the one that failed, users go into resilience mode, right? But the users can then therefore retain their connection to the conference because the conference is still ongoing. We did not lose the conference MCUs that are associated over there in pool 2. And so on, right, as you look down. Things like contact lists and address book, right, are not available, but things like peer-to-peer sessions and modalities are available, as obviously a pool doesn't have any impact on that side. The Lync backup service is the process that runs in the background and automatically exports and copies the data to be available on that secondary or backup pool, in that case of the outage. We call out from a support perspective that when you pair pools, we require Enterprise Edition pools to be paired with Enterprise Edition and Standard Edition pools to be paired with Standard Edition. We did not test the alternate or the cross functionality there, right? So if you go into Topology Builder, you will find that you are not blocked from setting a standard pool as a backup for an enterprise or vice versa, but we don't know what will happen, right? We didn't go through that test scenario, so therefore it's not a supported process from the Microsoft side. By default, we synchronize that data every 2 minutes, so to make sure that we have a accurate list of all the conferences and or contact list changes, right, that users may have made on their primary pool to reduce the amount of data that gets lost in the case of a pool outage or a pool failure. Those changes are exported into zip files and copied by the backup backup service over to that backup pool. Source pool gets the files, imports the data, sets a cookie as a high watermark, and therefore it's aware of the last state or the last status change that it received from the primary pool. And obviously this service is working concurrently, right? So pool B is backing up pool A, and pool A is backing up pool B. Therefore, a loss of either of those can be readily resumed from a user perspective in that environment. The backup store uses a file share to copy these zip files to, so we define that backup store topology builder. We'll write to that backup store, copy the files, import process then to import the files on that secondary pool or the backup pool in the organization. For splitting users across the pools, we typically recommend that you it's close to 50-50 or where the general user population is. So if I have 2 pools in 2 different locations and I've got user populations at each of those locations, I'd home the users at location A on pool A, home the users at location B on pool B. If the users are not homed at those locations, we tend to prefer the concept of 50-50 over 100% zero, primarily to ensure that in the case of an outage, half of the people are not affected by the outage at all, right? So their conferences, their calls, et cetera, are all going to proceed as designed or as in process. The only people that would be affected by the outage would be the ones on the pool that failed. If we have the 100% zero scenario and we have a pool failure, we obviously impact 100% of the users inside of the organization. So let's go. How are we doing on the CMS here?
Absolutely fine. So for those of you who've been watching me, I have been typing away furiously, just making sure that everything has synced up okay. I haven't done anything more than the invoke CS management server failover commandlet that I just showed you. I was just checking that the management store replication status was set to true for all of the servers in my topology to make sure that they were aware of that change. And once that was set to true, I then ran the get CS management store replication status -central management store status commandlet that you can see on screen right now. And you can see that the active master FQDN has now changed to FE3, where it was previously FE1. So the CMS has now failed over to the second pool, which means I can go ahead and fail over or switch over my pool 1 users to start using their associated backup pool. So because I have an edge server in my environment, I need to, what do I need to do? I need to set my CS edge server, that'd be good. And I need to update it to point to pool 2. So when users connect in, we need them to be switched over to the registrar pool 2. So obviously typing and talking at the same time is challenging, but I'll do my best. So that updates my edge server, so it should know to send users to pool 2. What I'm going to do at this stage is just do a get CS registrar configuration, and we should see at the moment that registrar pool 1 is currently set to active as a pool state. And if I was to have a look at my user, we can see that my user currently is still connected to FE1. So although the CMS has failed over, the pool has stayed up. It hasn't actually impacted the users at all. And as you can see, whilst you've been away, people have been writing stuff here saying nothing has stopped working because the conference has been not interrupted by the CMS failover. The last thing I'll do is show you the GetCS backup service configuration and just show you that we have a sync interval. And the sync interval is the process Andrew was talking about earlier on, where we replicate the changes over between the pools. And by default, that's set to 2 minutes. I've reduced it to a 10-second interval here, just to speed things up in a lab environment, but normally that's going to be 2 minutes. This really is just for lab use only. So the next thing we do is a pool failover. So invoke CS pool failover, specify the pool FQDN I want to failover, and that would be pool 1. And if I execute that, tense, nervous moments. Everything's worked beautifully so far. And it's still working beautifully, it's just taking a little bit of time.
If you watch the virtualization session this morning and you talk about undersized resources, right, this is the end result that you would have.
Yeah. Running your entire Lync environment on a laptop Probably not a great idea. So what's happening here? It's a very straightforward thing to do. You run the invoke pull failover commandlet, and that commandlet does a whole bunch of stuff in the background. So you can see here it's doing gets for some of the Windows services. It does a ton of stuff, and you just let that run, and that'll take a couple of minutes. So we'll come back and see that failover. Before we do, this conference is going to fail whilst we fail over. And you can see there that that's failed for right now. You'll also see that the user has signed out. So the user experience for a pull failover is they do get signed out. And they get the message saying there's a network or server outage temporarily limiting your client as they sign back in. So you can see now my client is now trying to sign back in. And I'll go into that limited functionality mode. Very, very quickly, as we fail over, we will be able to rejoin the conference, and we should be able to see that that conference data has persisted across the two pools.
Okay, so we talked about some of the backgrounds, right, of how to configure the concept of pool failover. There are some best practices or recommendations, as we called out earlier, pair enterprise to enterprise, standard to standard. We also tested virtual, physical. So our support boundary, our support stance is what we had on the test matrix there. Like we called out also, right, topology builder is not going to validate this, so you may be able to achieve other results in your environment. What we know works is the one that we put on our test matrix, which is the one that we're calling out. There's a capacity planning portion of this as well. We have two choices for your environment. One is that we size each one of the pools to service 100% of the users, meaning they're running at 50% capacity during normal operations. And that ensures that when we do have a failover event, you will have a normal user experience once the users are activated on the remote side. The other option also, right, is to have each pool sized for the user load itself. And when you have a failover event, you'll have a degraded user experience as you won't have the full capacity, right, for all of that user environment. The other aspect, as we call on the bottom bullet there, is a concept of the back-end infrastructure. So from a paired pool perspective, if we're using enterprise pools, we can do SQL mirroring on the back end. That ensures that we have a high availability or no single point of failure on either individual pool. So we can lose either front-end servers or back-end servers on either pool without having that pool failure mode instantiated. If we have a standard edition server, right, loss of that server is always going to call out or instantiate the concept of a pool failover to a backup pool. When we look at the capabilities of the difference here between high availability and site resilience or disaster recovery, what is the functionality that's provided in that, first of all, a server failure, right? So in HA, we're talking an individual component, whether it's a back-end server or a front-end server. We can see that we have all functionality. Clients do not notice, they do not sign out or sign back in. They will just automatically work in the case of one of those failures inside of a pool itself. When we talk about a pool failover, or the steps that Ewan is showing us, right, we have nearly all. It's not the same as the concept of an inside of a pool failure. When we have a full pool outage, we do have some functionality that will be missing even after we go ahead and activate the users. So we have from a CDR QoE perspective, we're still set or configured to point to the other one, right? Or if that QoE database was at the site that went down, we're not able to update that from that remaining pool. From a voice perspective, things such as the response group service and call park, as well as call admission control, are also unavailable for the users during that pool failover experience. This references back to the kind of the earlier comment, right? Obviously, these things are on our agenda for updating as we ship. We just have to choose ship times sometimes that don't allow us to get perfect functionality. If another way to look at it is if we waited for Lync 2013 to be perfect, there would not be a Lync 2010 or 2013, right? We'd be waiting for Lync 2016 back from OCS 2007 R2 in 2009. So we add features and capabilities, we'll fork it to ship, but continually in the background, the dev are working on the code base to try to improve that experience and simplify it. So from a 2013 perspective, right, you're seeing a lot more functionality on the pool failover side than we had with Lync 2010. For our pools, as we call out, right, the registrar relationships from a front-end perspective are always going to be one-to-one and reciprocal. So pool A will only ever fail over to pool B and vice versa. You can't have pool A to B, B to C, and C to A, for example. It's only a paired or a mutual paired relationship between those pools. And although we can have any pool in the environment, right, or any equivalent pool, so as long as we have Enterprise Edition pools, another Enterprise Edition pool, or Standard Edition pools, or Standard Edition pools be the failover, we still may have survivable branch appliances in the org that are pointing back to one of those pools as the registrar, or the backup registrar from an SBA perspective. What we do not have in the pool failover mode is the ability to have those SBAs also realize that their backend pool has failed over to a secondary pool. So the user experience on an SBA in a primary pool outage would be the loss of conferencing, loss of instant messaging, right, for people outside of that environment or location. They're going to go into the SBA resilience mode and have local functionality only. That's another area, right, that we'll continue to work on. But for now, the pool failover experience is limited to people homed on pools themselves. It does not include users who are homed on a survivable branch appliance or an SBA. How are we doing on the demo?
It's time to pop back. So for those of you in the auditorium, if you're listening to the recording later, you won't know this, but in the auditorium, you did not see me type anything. I was just wiggling my mouse, looking, waiting for things to happen. And you can see that this is the kind of stuff that we used to put in KB articles and say, here are all the steps that you have to perform a failover. And, you know, it was kind of complex. Now you just type in one command, the pool failover happens. You can see all the stuff that we do in the background, and there's a lot here. And there's a bunch of HTML files that give you statuses as it goes through the whole process. And eventually we get to a state where if I do get CS registrar configuration again, we should see that pool 1 currently has a status of failed over. And if I get a CS user pool info for my user, there we go. That should give me some slightly different information to what I had before. Whilst that's running away in the background, I can actually check from the client side as well, just to show me what I'm going to see in PowerShell, that the user is now connected into pool 2. Now, I didn't do anything from a client perspective to make that happen. I will admit to touching my mouse. I won't admit to clicking anything. That just automatically happened. So the last time you saw this Lync client a few minutes ago, we were in the resilience mode, where we had limited functionality. The client's just automatically, within a couple of minutes, flicked into essentially full functionality right now. You can see that the conference hasn't been rejoined. I actually have to rejoin the conference. It's not a big deal. We just rejoin that conference. And within a moment or two, we should see that that data is still there as we rejoin the presentation. So that's failed over from one pool to the other pool automatically, just with those couple of PowerShell commandlets that I ran. And we can also see here that the user, the primary pool is still pool 1. They're just failed over at this stage. We haven't actually moved them. They're not now on pool 2, although they're running out of pool 2, out of FE3 and FE4. The very last thing to do, once I've patched, done whatever else I want to do on my pool 1 side, is I can invoke my CS pool failback, and that will invoke the failback from pool 2 back to pool 1 for my users. And at that stage, I can make a decision about whether I want to leave the CMS at pool 2 or move it back to pool 1, SQL 2 or move it back to SQL 1. At that stage, it really doesn't matter.
And so we'd invoke that process, right, in the case, as Ewan says, either we have a known a planned maintenance event on pool 1, or in the case of a pool 1 failure, all that data has already been replicated to pool 2, and you'd invoke that command to activate the users on pool 2 that were originally homed on pool 1 so that they can regain their full functionality. So now that we understand this concept of pool failover and a lot of the work we're doing to make that failover experience as seamless from the end user perspective as possible, right? So no re-authentication from an end user perspective. The client will sign back in automatically in resilience mode, and once they've been activated on the backup pool, automatically go from resilience mode into that will say nearly full functionality, right? They still won't have CAC or response groups or those the 3 rows that had the red check mark. But from a conferencing, from a voice, from a video, from an audio perspective, they'll have their call forwarding settings, right? They can place and receive telephone calls, rejoin their conferences, their meeting invites that they sent out to people will continue to work. Other functionality would work as planned. So you might wonder, right, as we talk about this concept of pool failover, once pool failover matures to a robust enough level, what would be the reason or the rationale for deploying an enterprise pool versus standard edition pools? And when would you choose one versus the other? And so we kind of call out, right, no enterprise pool. When you have pool failover, that might not be a problem, right? You can still get away with a lot of the functionality in terms of providing availability. You'll have clients automatically sign into the other side. You push a button, those users will have most of their functionality back. It's not quite the same experience as a component failure in Enterprise Edition pool where it's fully automatic and the clients will talk to another front-end server. But that Enterprise Edition pool requires a SQL mirror potentially, right? Requires, our recommendation is 3 front-end servers per pool. That's quite a lot of infrastructure to deploy, especially when we look at the smaller or mid-sized organizations. So from a discussion perspective, right, we're looking at and have a lot of discussions with customers about when should you start looking at standard edition pools as your all-in Lync replacement versus enterprise edition pools. And it turns out that's not a simple conversation, right? There's no easy dial that says, you're a customer that's destined for multiple standard edition pools with pool failover. You're a customer destined for some enterprise edition pools with hardware load balancer requirements and SQL and other components required around that. Advantages, right, are we don't need things like HLBs and SQL. Those are typically complex and or expensive. No DFS or file share. If we have an outage, it's just that server. It's very easy to recover or repair a Lync server. We just flatten it, rerun setup, right? The paired pool functionality will bring the users back. The information stored in Topology Builder. We don't need to run backups on those. We have that information being backed up automatically via the pool failover concept. We've done the math. It turns out that up to 40,000 people, you actually will run fewer server instances using standard edition and pool failover versus enterprise edition, SQL mirrors, and the 3 front-end servers per pool type of experience. So until we get to very large organizations, typically standard edition is much more cost-effective just from a server footprint alone, right? Not counting the overhead or additional infrastructure required, such as hardware load balancers and SQL, et cetera. We can load users on those pools, either active-active or active-passive. Our preference is always active-active, just to reduce the number of users affected by any individual outage. And there's some other changes structurally that occurred in Lync that also enable this more in Lync 2013 than what you could do via manual steps in Lync 2010. One of the big ones is if you're using Lync as your PBX or voice routing functionality, we no longer have the mediation servers associated and have some route specificity there based on the pool itself. So because we can now do selective trunks, and we can route based on a trunk that's available inside of the organization, if the front-end server, or the standard edition server that housed one of our trunks is down, there's another trunk that's active. When we activate the users on that other pool, they're able to leverage the surviving trunks that are there for outbound. Other users on other standard edition pools in the organization will not be impacted by the loss of that server in the trunk, as they'll still have access to the other redundant trunks that have been provided there already. So this table shows, right, as we talk about server counts, it's really up to 40,000 that we will see a fewer number of servers deployed, providing nearly the same functionality when we talk about Lync Standard Edition versus Lync Enterprise Edition. The concept of Standard Edition and the brick model also aligns with that concept we talk about of trying to move away from clustering and single points of failure and have just multiple Lync servers, all identically configured, all listed in Topology Builder. Any of those servers fails, you wipe it, you run Lync setup on it, you the pool failover, right, will replicate the information back. We then activate that, invoke the pool failover to bring the users back to that pool, and we recover that server using only Lync commands, right? No need to worry about restores and times and other backup functionality around that. And during that pool outage, we have the concept of the pool failover, right? The invoke CS pool failover, which means that users who are homed on that pool will be activated and run successfully on the backup pool that was paired with their failed one. From a design perspective, there's some questions that we have to answer also. When we have the concept of enterprise edition pools, we might have directors or other ways, and typically those will be the endpoints for client registration in the environment, or where the SRV records will direct the clients to register to. When we have, let's say, 10 or 20, or in any case, more than 2 standard edition pools, we'll have to choose in DNS which one of those pools we want to have the highest priority, or do we have 4 to 6 pools all with equal priority, and assign those the associated or the equivalent SRV weights. We also have some certificate requirements there. We can simplify that by using wildcard certificates out on our reverse proxy environment, because each standard edition server in the environment is going to require an external web farm FQDN entry. So there's with each Lync pool, we have an internal web services URL and an external web services URL. If we have just 2 enterprise edition pools, that's 2. But if we had 6 standard edition servers doing the same functionality as those 2 enterprise edition pools with 3 servers each, now we're looking at 6 external FQDNs, right? So we have some potential additional SAN entries on certificates, but not a major overhead compared to typically the reduction of server counts required inside of the organization. So lots of good things about standard edition pairing, but as of now, right, it's still not as seamless or as ideal as the concept of a component failure in an enterprise edition pool. We do have a time component for that activation. We say that the target or the design guidance we used was 30 minutes, and so obviously it will take some time for you to determine that there's an SE pool failure in your organization, and you'll have to go and execute the invoke CS pool failover commandlet that Ewan has called or has executed for us, and then have those users activated on their backup pool. That's some time. During that time period, they operate resilience mode. We had the slide a few slides ago to kind of call out what that functionality is for end users. We also have the question, if you only have 2 enterprise edition pools, it's relatively easy to balance your users. They're on one or the other. But as you start to grow lots of standard edition pools, you'll have to figure out how to provision users, right? So do you randomly spread them across these pools? Do you have some logic associated with that? But there's some administrative overhead with carving out which users go to which pool. The other concept here is because we only have a single server for pool, there's some impact from other Lync services. So in Ewan's example, right, we had 2 enterprise edition pools. Your edge servers in the environment have a single next hop defined. And so if one of the pools that failed is the next hop from inbound from edge, when that fails, you'll also have to go to your edge environment and update that to point it to one of the servers that survived inside of the organization. Response groups, as we called out, are not something that will fail over and fail back. So if we do have response groups and they're on the server that failed, that's still a manual export and a manual import for us to restore that response group functionality. That applies also in the enterprise edition paired pool scenarios. If you remember on the slide prior, right, response groups, CAC, and QoE are the 3 services that we don't have automatic failover for. We say potentially more complex to manage, primarily just because there's additional pools, there's some other namespaces, there's the decision points on how to carve out how your users get provisioned, but then that's balanced by not having to administer SQL in the environment, not having to administer hardware load balancers, and not having to worry about things like Quorum or Windows Fabric that become associated with the concept of enterprise edition pools. So they each have some complexities from an administrative perspective, and they each have some advantages from an administrative perspective. It's up to you to kind of balance through those. We tried to list some of those pros and cons here on the last couple of slides. The last one, and this is one that we had in Lync 2010, is this concept of metropolitan data center. When we initially started deploying Lync 2010, we had a couple of customers in the US that have extremely stringent RPO and RTOs, and they wanted to have their Lync environment in 2010 survive a single data center failure. What we had was some of our groups in the product team and services kind of go on site and work out what that process would be. They documented it. It came out as the Metropolitan Data Center design. It was published out on TechEd. The complexity, however, resulting from that has led us to not recommend that for a majority of our customers and to actually remove that as a supported option in Lync 2013. And the reason behind that is we say if you have a single pool, if it spans locations, you still have a single point of failure, right? And so whenever we have a single point of failure, if we have an outage somewhere in that chain, it's going to affect the entire pool, and now we have an entire outage. If we only had one pool spanning in our metropolitan area, we spent a lot of money to design something that at the end of the day still can go down for our users, probably with more regularity than if we had just stayed simple and deployed 2 pools, either Enterprise Edition or Standard Edition. So for Lync 2013, we do not have an option. If you have a metropolitan pool scenario for 2010, you'll have to move to a paired pool scenario for Lync 2013. So our recommendation and guidance, right, do not stretch your Lync 2013 pools. We'd rather see you go down the paired pool process and rely on our cumulative updates and patches to Lync to help enhance or upgrade that service as we continually move through.
And we have a question over here.
Yes, thank you. So the question from the audience is, where is the single point of failure in the metropolitan site resilience one? In this scenario, what we have is SQL stretched between both locations and synchronous data replication at the storage level. So we have a single storage system, well, 2 storage systems set up with synchronous replication. We have a failure at that storage system or at the SQL layer, and we have a pool outage. We also have the risk that there's a code base or a quorum issue potentially, right? So if we look at the concept of quorum with 2 locations, we'd have to ensure that the loss of one location would allow us to survive the second location and still maintain quorum. We don't have a process for that in Lync 2013 like we do in Exchange. So in an Exchange, you can have a DAG, it can span locations, but if the location that has the majority node loses functionality, right? We have a power outage there, for example. One side has 5 nodes, one side has 4 nodes. We lose the 5-node side, 4-node side automatically goes offline. And so whenever we're talking about stretch and we're talking about clustering, we have the concept of quorum. Once we have the concept of quorum, we don't get automatic failover for a majority of those types of scenarios. So when we're stretching a pool, we have the concept of storage and we have the concept of quorum, and that prevents us really from having that automatic style failover experience. A paired pool scenario, clients will automatically re-register the other paired pool. You push a button, you've activated it on the other side. If you want a quote automatic, right, you can write a PowerShell script that looks for that pool outage, and after a defined period of time for the pool outage, automatically invokes the invoke pool management pool failover process, and you've essentially defined a manual automatic, right, automatic failover type scenario. But in general, what we found is most customers in the outage scenario want to make the decision of do I activate or not, because some cases it's a very intermittent outage. It might be a network hiccup, right, or something like that that just dropped connectivity for a short period of time. If you think it's going to be restored quickly, no point in rehoming or activating your users on the other side. If that outage is going to last for hours, in that case, push the button. Within a few minutes, you'll have all the users activated on the secondary pool, and the functionality is up and ready to go. Are you, did it fail back successfully?
It fell back successfully, yeah. So if we switch back to my screen, I accidentally closed the conference, but I guess you get the idea. So what we have here is the invoke CS pool failback. I really haven't done anything else aside from this. So if I have a look right back up here, you can see again a ton of stuff has happened. So I've literally just run invoke CS pool failback. I neglected to type in the pool name, but it prompted me for that anyway. So I typed in pool 1. I confirmed that I wanted this to happen, and then it just automatically ran all these steps and performed all of this logging as well. So without going through all those individual steps, you can see the last thing it did was start all of the services on the machines. And if I quickly right-click my client and go to configuration information, again, we should see that that user is connected back to FE1 on pool 1. So essentially with aside from the PowerShell commands we use to check the backup status and the relationships, essentially it's a PowerShell command to fail over the CMS, it's a PowerShell command to fail over the pool, and it's a PowerShell command to fail back the pool. Everything else that you need to do, all the other steps, are looked after by those 3 PowerShell commandlets.
Right, so we ran some extra PowerShell commands to try to show status, right, and give you some additional information. Those are obviously not required to do the actual failover and failback. Question?
What are the implications of having, if you had two pools paired and had SQL mirroring from the primary pool's database mirrored to the secondary pool's database server?
You've designed a de facto metropolitan site resilience update. So it wouldn't be two pools in that case. You'd have a stretched pool because the secondary pool, if it's talking to the other node in the mirror, right, would not be a second pool. It's actually separate servers in the same pool. You see where I'm going? So if, the question was if you, I forgot if I repeated the question. Question was what happens if you take your SQL mirror, put one node in location A, one node in location B. In that case, you've essentially stretched the pool because the nodes in location B talking to that part of the mirror would be part of the same pool, right? We can't have pool B talking to SQLs from pool A. You're welcome. Oh, let's, do you want a Blackwire 520 or a Blackwire 510? I'm guessing it's better as well. We haven't looked. You're welcome. And yes.
With the changes for support for SQL clustering, under what circumstances do you recommend using SQL failover clustering over mirroring?
Yes. So we're getting past the what's supported into the what's recommended realm. Question is, we recently changed our support stance. So our support stance at RTM was if you had SQL clustering in Lync 2010 and you migrated to Lync 2013, we would support you on clustering. But if you're deploying net new Lync 2013, we did not support clustering. We wanted you to deploy a SQL mirror. We had a lot of feedback from the external and internal community saying, well, what if I just deploy Lync 2010 with a cluster and then go to Lync 2013? I'm supported, so why don't you just support it anyway? So now we do support SQL clustering with Lync 2013 as well. From our perspective, if you have a well-run SQL administrative team and they're confident and comfortable with the concept of clustering, and you have a historical record of high availability on that SQL cluster without long-term or extended outages, you're welcome to go with the clustering side. However, that means that you're now involving a different group in Lync operations, right? So you're having to involve the SQL team when you're potentially doing failovers or patching or management, as that's part of your quorum. And if they do patching there and you do patching, you could end up losing quorum, for example. So there's some administrative overhead to that. It's fully supported. The Microsoft preference is to go towards the concept of mirroring just to reduce the single point of failure, but we re-added support because we understand that's a very common scenario, right? So in some organizations, the Lync team may not have the authority to deploy their own SQL mirrors. They need to rely on the SQL will work with the SQL team, right? And so in that case, work with them. If your SQL team has given you poor support, we'd say maybe raise your hand and have this discussion around SQL mirroring, but if you've got a good rapport with them, and they've done well in the past, they're probably going to continue to do well, right? And using a SQL cluster in that case should be fine. We have a Blackwire 510 and a Callisto 620. Callisto. Question. Question is, what scenario would you use the dash force commandlet on a pool failover? I'll answer this and I'll have Ewan correct me after, after I go through. Dash force, let's assume that we had, so one of the things I wish the Lync side would do, right, is on Exchange, we have the concept of switchover and failover. And I've got you up next, thanks. So a switchover is a planned administrative event. A failover is when we had an unexpected outage and we take some administrative action to then recover from it. In Lync, we use the word failover for both. So force essentially is our way if we had an unexpected outage and we try to do a failover, but the failover fails because some of the components aren't available to do a proper shutdown, right, and a proper failover, we can invoke it with force to force the process. Is that?
Happy with that.
Would you have add any color to that?
So that's CMS management failover has the force parameter, the pool failover has the disaster mode parameter, which is essentially the same thing of the primary pool is not available, so we just want to forget about connecting out to that, touching it, and just bring the secondary pool online.
So there seems to be a lot of, or you need a lot of service to service a pretty low amount of users. So about 6,000. So there seems to be a large amount of service to service quite
Yes, the question is, from a user perspective, we often see a large, so from a user perspective, it's common to see a large number of Lync servers in the organization used to support the Lync workloads. The couple feedback points we have on that is we've tried to reduce it in Lync 2013, so we no longer have like AV, MCUs, and whatnot broke out. But at the minimum footprint, right, I would say you'd have 2 front-end servers, or sorry, 2 standard edition servers and 2 edge servers. That will support per standard edition server about 2,500 people. So if I wanted pure failover and 50-50, right, I would say that those 4 servers would support about 2,500. To add additional people to that means we're adding additional servers. And so the question is, if I have large numbers of people, right, would Microsoft look at scaling up versus scaling out? The scale up versus scale out discussion has been pretty active inside of our organization the past decade, and the approach has been to scale out purely from an availability perspective. So the goal is to reduce the number of users per footprint, to not have the, quote, all your eggs in one basket, because that way we can lose any individual component but have a smaller number of users affected. We target the 2-socket server footprint as our standard hardware chassis. Our guidance typically will show you 2 sockets, and those are today, right, probably quad, hex, or 8 cores on those 2 sockets, and some amount of memory and some amount of local storage, and then have a number of those distributed in the organization to provide services, whether it's Exchange or Lync or Active Directory. We found, if you look at the availability model, probably our most available service that customers have deployed is Active Directory, and the way we achieve that is by having software replication, single servers, right, and this concept of read-write replicas or masters inside of there to achieve the functionality. So we can lose domain controllers at any point in time, but from an end user perspective, they can still log in, they get their logon scripts, they get their group policies, they have functionality. Their location, they might be a little bit slower, but they're still not prevented from accessing the service. We tried to steer or direct from the Exchange and the Lync product group perspective. That's the model effectively that we're moving towards, which is to try to get containerized modular servers, all configured identically or near identically, right? One obviously is going to be the read-write master typically, and then have this concept of software replication and either database availability groups in Exchange or pool-level failover in Lync to ensure that the service survives in a single server or multiple server style outage. If we look at the concept of scale up, we can run significantly larger or higher quantities of users per server, but once we start to get into even today, the servers will support, several, an Enterprise Edition front end is around 6,000 users per server. In Exchange, we've seen orgs put around 5,000 to 10,000 users per server. Once you start to go above that, you just start to get so many users on that server that the common failure, the server failure scenario, impacts such a large number that it's frowned upon typically in the design phase. So we like to see numbers of around, let's say 6 to 20% of your users per server. You lose any one of those, a subset of your user population gets lost, but the organization as a whole will continue to work. And for that subset, we're trying, for Lync right now, right, in pool failover, you'll have some administrative action to recover. From an Exchange perspective, you'll have some automatic failover options going forward in Lync, right? We're trying to make that failover process automatic. So it's a long answer to a shorter question, but in general, the philosophy is to try to go down that Active Directory model. That Active Directory model also happens to be the one that all the cloud service providers use. So if you wonder about the availability of the Gmails, Yahoos, Hotmails, et cetera, or Salesforce.com, all of those are using the same modular brick approach, little 2-socket chassis, lots of those software used to replicate the data between them, and regular failures, right? We anticipate, and they actually have teams going around causing random failures, unplugging things, and making sure the developers are on their toes to ensure that any of those random failures do not bring down the overall service, and you have a rapid recovery process to a neighboring or nearby server, either in the same location or in a different location, to keep service availability. So what we want to see is, from a Lync client perspective, you're signed in on your phone or your tablet or your computer, you should not be aware of what your pool is, right? Ewans of the world might like to control click and see where their server is and use that to figure out what's going on. But for your typical end user, they just want to sign in and see that they can join their conference or place a phone call. So having that brick model is more likely from a mathematical perspective to give you that availability. And so we follow the probability model there. There's actually a good post on the Exchange team blog about a year ago or so where people were talking about numbers of copies of your data. So in Lync, with the paired pool model, we essentially have 2 copies of your data. Well, in enterprise editions, we would have more than that. Standard edition, we'd have 2 copies. From an Exchange perspective, right, in a DAG, do you go with 2, 3, 4, 5? What's the magic number of copies? And assuming a 5% disk failure rate and a 0.5% or so hardware failure rate, which is kind of the typical failure ones, 4 copies of the data gets you 99.995% availability. So if you have 4 instances in your organization spread across more than 1 location, at least 2, maybe more, mathematically, right, so in a perfect world, we can get you 99.995%. You add in human error, code problems, administrator problems, right, we're going to take a % or 2 off of that, but that's the goal that we're shooting for. Question?
Given that the writes back to the database are now lazy,
Yes.
are there any latency around there, any sort of rules of thumb around latency?
I thought he was going to throw it, sorry. Question is, now that the writes back to the SQL database are lazy writes, right, we're going to cache or queue those up on the front-end servers prior to submitting them back to SQL. What's our specifications around latency? We still say that we want the SQL server or backend server close proximity, meaning probably same subnet or same data center typically, right, from the front-end servers. I haven't seen us publish any numbers saying it could be up to 10 milliseconds or 20 milliseconds or something like that, because if we do have a SQL outage that's more than a few seconds long, essentially, we will have that pool go into resilience mode. So we don't want to see resilience mode just because there was some network delays, right? We only want to see that if there really was an outage. So no significant changes there. Question?
Can we have 2 standard edition in site A and 1 standard edition in site B so that we provide HA for site A as well as a DR?
Yeah, so question is, can I take 2 locations and put 2 standard edition servers in site A, 1 standard edition in site B, and then have high availability in site A and site resilience with that disaster recovery site? Not today, because we can only do pairs. So you'd have to have some combination of 2 plus 2. So your minimum footprint is 2. Your next step up from that is 4, because we can't have a tertiary pool failover point. So you'd go, the answer to that would be 2 plus 2 with each site backing up the other site.
And
2 standards and 2 standards. It's possible to do 2 standards, but they'd only be in a paired relationship. We couldn't have 1, 2, 3, 4, for example, right? So if we had 4 pools, 1 and 3 would back each other up, and 2 and 4 would back each other up, but we wouldn't be able to do 1, 2, and 3 in some sort of combination. Mutually, it's only 2, no more than 2, and must be identical. So A can only go to, if A and B are paired, there can be no C in the mix, right? So A can only go to B, B can only go to A. We can't have A to B, B to C, C to A, for example. Question?
Just from what you've been saying about the metro data centers and all that sort of stuff, from what I understand, if you're doing a standard installation across two different sites, the really minimum you're going to have is 4. So 2 edge, 2 standard.
Yep.
If you're going to do an enterprise edition thing, you're going to end up with 12.
Yes. So the question is minimum footprint for standard, right? If you look at edge and internal would be 4. We probably would say 5 because we really like the monitoring server role, which would be a SQL database in this case, to capture the call detail records. You probably have a SQL database already running we can point to. But
SQL mirror in each site as well.
right. So but if you go to enterprise, I think it goes from 4 to 12 because we have, from our recommendations, right, 3 front-end editions per pool, 2 SQL mirrors per pool, a SQL witness per pool, which is 6 to 12, plus our 2 edge servers, which is 14. And so you can see why we're seeing a lot more traction around pairing standard editions with pool level failover versus doing a minimum footprint enterprise deployment to ensure you have the concepts of quorum and clustering and SQL, et cetera, on the back end. that's exactly driving the last 4 slides.
Is there any recommendation for the installation of the SQL mirrors so that you separate out the instances for each individual service, like persistent chat, archive monitoring?
Yes, so question expands to what's recommendations around once we have a SQL mirror set up for our pool, what services can we co-locate in that mirror? So an Enterprise Edition pool requires a SQL instance, monitoring requires a SQL instance, archiving requires a SQL instance, and persistent chat requires a SQL instance. And those today have to be separate instances. Have we changed our guidance? Is our guidance still pool SQL instances must be separate from monitoring archiving? Monitoring archiving can be co-located on the same SQL database, and persistent chat is typically our recommend. Persistent chat is interesting. Persistent chat is complex because of the user models around that. It really depends on the usage. A heavy persistent chat model, we will say you'll need a dedicated SQL instance for it. If you're using it for a subset of your user population and it's more help desk functionality and not several hundred active traders, you'd be able to co-locate that sort of functionality. I think our current guidance, and are you checking right now?
Yeah, I'm checking.
Yeah. I won't say it because this is being recorded. I believe right now that we require the instances to be separate from a pool perspective, but we can co-locate the instances from a monitoring and archiving perspective because those are lighter usage loads. But there's been questions about what is in smaller orgs, when can we co-locate that? And that's what we'll check up for you on. Yes?
Just going back to the slide there previously about pairing a standard edition with an enterprise edition pool.
Yes. We don't know. You can do it in Topology Builder. Or at least you can as of the last cumulative update. We might block that at some future cumulative update because we don't recommend it. What happens? We never ran that scenario, right? So will it work? Probably, maybe, but not supported. Yes. So that's the not supported because we don't know, not supported because we tested it and it failed. Yes.
Has there been a change
Oh,
to the Lync?
2. All right, gotcha.
Has there been a change to the Lync 2013 one so that with 2010 and enterprise pools, when the client pulls back to the server, caches back the pool members. So in the instance of a failover, it's obviously already got that cache
Yep.
back on the local system. When we do SRV records with different ratings, does the client now know about the other single standard edition pools? Because they didn't before.
Yes.
The trick was to make them force a failover to get it into their cache and then rehome them again.
I'm going to defer. I have a longer answer to yours, so I want to see if you have a quick answer or not. And I'll come back to that one.
Before we take that question, just to go back to the question of
yes.
co-locating databases, yeah, we can co-locate everything on the same database server. We just can't have multiple pools on the same database server.
So we have revised our guidance on that one. You can co-locate.
They can be all in the same SQL instance, yeah.
And that has changed. You're welcome.
When you say maximum number of users per server, is it during the failover scenario or without?
So question is, the maximum number of users per server, that's without pool failover. So if we say 2,600 users per standard edition box, if you put 2,600 on each and you set up pool failover, you'd have 5,200 and you'd have double the load that we would plan for. That 2,600 number, by the way, assumes that you're using all functionality in Lync and that your users match the user profiles that we've documented out on TechNet. So number of people in conferences at any given time, number of audio video conferences, number of HD video conferences, et cetera, et cetera. So.
Other question is, now, does it matter how many endpoints a particular user has? Like, where is the bottleneck?
Yes, yes. For a sizing perspective, I think, so the question is, from a sizing perspective, we say 2,600 users. What's the number of endpoints users might have? I think in our sizing guidance, in our user profiles, we estimate 1.6 per user. So that 2,600 is assuming that people have more than one, but not like 3 endpoints per user, per user talking to Lync. So there is some assumptions there on some concurrency on endpoints that are attaching. It's not double I think it's 1.6. I'd have to double check on the user profile. But we do assume it's more than one.
And how about like if you provide OI mitigation and stuff like that, does it consider that as
That would be an endpoint from a usage perspective. We would see OA just as like a Lync client or a mobile device signing in. And
for our typical user normally, let's say they have some sort of a tablet device on a mobile phone and also, Lync running all the time on the computer as well, so that would be 3.
that's 3, but so question is, let's say that your users have a desktop or laptop, right, a tablet and a mobile device. Is that 3 endpoints? It's 3 endpoints, but I want to say that mobile endpoints are classified a little differently because they're not running as actively as the desktop endpoint is in terms of showing presence and expected activity. We get deeper into the user profile section there. There's a pretty lengthy page on TechNet that talks about what our defaults are that lead to that user sizing, and we've requested guidance on if you deviate from that, how would you come up with hardware planning, right, or sizing requirements based on you have fewer audio-video conferences or you're not doing enterprise voice, for example. So that guidance, last time I checked, the last few weeks, it's not published yet, but we have requested that, so it's in the pipeline.